Yeah, after that completion of FST 5 paper 1, let's move to paper 2. In this, the number of questions are, the quantity of the paper is less, which means number of questions are less. In this, reasonably given few questions of both the physical as well as inorganic. Let's see here, section 1. In the section 1, the question number that starts with the question number 37. So in this question number 37, they have given an expression or an equation Pb solid plus PbO2 plus H2SO4 aqueous Q raised to PbSO4 solid plus 2H2O. It is a lead storage battery. Given, they are asking what is the equivalent weight of H2SO4. So in this, what could be the equivalent weight of the H2SO4? When they asked, now we have to see them. If you want to balance, you can balance the equation. Otherwise, also we could do. Now you see here, if we balance that equation, here we have to put 2 PbSO4 first, and here also this is going to be 2 H2SO4. Now 2 into 98 grams, which are reactive. The equivalent weight, here the X factor is equals to 2, such that 2 into 98 divided by 2, that is equals to 90. I am telling you once again, listen. Sir, what is this? H2SO4 equivalent weight is equals to 49 only. Now why we are writing here 98? First balance the equation, then you can find 2 into H2SO4. 2 into H2SO4, which means 2 moles of H2SO4 is participated. 2 moles of H2SO4, which means 2 into 98 grams that we have taken. How much is participated? 2 into 98 divided by 2. Therefore, overall 98 grams, which is participated in the reaction. Therefore, its equivalent weight is equals to 98. Next question. Question number 38, which is there in your DPPs also, DPP book also it is there. I guess some similar type of question is there, not exactly same. An ideal binary liquid solution of A and B has a vapor pressure of 900 mm of Hg. Yeah, we have a solution. Here we have a solution. This solution PS, that PS equal to P naught A XA plus P naught B XB is equals to 900 mm of Hg. When this is heated, which is subjected to the fractional distillation, here it is going to form, some of it is formed as a residue and some of it is formed as a distillate. Some of it is, let us suppose that this is going to be residue and this is going to be the condensate, which means residue which is left over. And given that in the residue it is distillated at constant temperature till 2/3 of its original volume is distilled. 2/3 of its original volume is distilled. Remember this, we will use it later. 2/3 of its distilled. In this, the mole fraction of B in condensate is 0.3. The mole fraction of B in condensate, XB in condensation, is going to be 0.3. The mole fraction of A in residue is given as T is 4, it is going to be 0.3. Mole fraction of B in residue is equal to 0.7. Mole fraction of A in condensate is equal to 0.6. Simple mole fractions only, nothing, here nothing is different. Now, and also given another data, that is the vapor pressure of residue is, this one. The vapor pressure of residue is given as how much, which is given something around how much, 860. 860. Now let's solve it. So first we have an expression that is P0AXA plus P0BXP is equal to 900. Now we have one more expression that is P0 XAR plus P0A XAR plus P0B XBR is equals to how much? This is equals to 860. We know that XAR value 0.3 P0A plus 0.7 P0B is equal to 860. If you want to write, you can write 3 P0A plus 7 P0B is equal to 8600. Let us take it as an equation 1. And we don't know any other equation. Here also we don't know condensation vapor pressure. If it is given, we can extract another one more equation. By solving these two equations, we would have we would have solved P0A as well as P0B. But we don't know that. But they have given one thing, that is 2/3 of it is going to be distilled. 2/3 of it is distilled, which means if 2/3 of it is distilled, therefore 1/3 is going to be left over. Now let us apply law of conservation of moles. Law of conservation of moles. Let us suppose that number of moles of A is Na, that is equals to number of moles of A, initial number of moles of A, Na, that is equals to. Now it is going to be, we'll be having in the two ways, that is how much which is distilled, this is condensed, how much which is condensed. In this, the mole fraction is going to be, we know that 0.4 as well as 0.6. Here for A, we know that 0.3 as well as 0.7. In this, 1/3 is left, 1/3 left, that is residue. 2/3 is condensed, that is distilled over. So this is going to be 2/3 part and it is going to be 1/3 part. Now, here the total number of moles of A in residue, the total number of moles of A in condensate. Yeah, as we discussed, written here, law of conservation of moles. 1/3 part will be the residue is left and the 2/3 part will be the condensate. So now, total initial number of moles Na, which is equals to, here it is going to be 0.3, which means into 1 divided by 3 of Na plus Nb plus Xa of condensate 2 divided by 3 of Na plus N. Just to simply the law of conservation of moles. Now Na, which is equals to, this is 0.3 into 1 by 3 Na plus Nb plus this is going to be Xca, that is 0.6 into 2 by 3 of Na plus Nb. 0.2, this is 0.1. Now it is going to be 10 Na is equals to Na plus Nb plus 4 Na plus 4 Nb. That is equals to, this is 4 Na, this is Na, 5 Na, now it becomes 5 Na is equals to 5 Na. Therefore, Na is equals to N, which means initial number of moles of A as well as B both are same. Na as well as Nb both are same, therefore Xa initial is equals to 1 by 2, Xb is equals to 1 by 2. Both Xa as well as Xb, both of them are equal. Now for this we can write here one expression, that is 900 is equals to P0A by 2 plus P naught B divided by 2. That equal to P naught A plus P naught B is equals to 1800. P naught A plus P naught B is equals to 1800. Now let us suppose that this is equation 2. Here we are already having the equation 1. Now let us do equation 1 minus 3 into equation 2. So equation 1 we are already having 3 P naught A plus 7 P naught B is equals to 8600 minus 3 P naught A plus 3 P naught B is equals to 1800 into 3, that is equals to, now it's gonna be so 4 P naught B is equals to so now it will be P naught B is equals to 3200 divided by 4 800. P naught B is equals to 800. So P naught B is equals to 800. Obviously P naught A P naught A is equals to 1000 and P naught B is equals to 800. Now let us see the options. So first one, the initial mixture taken should be an equimolar mixture of A and B. That is true, correct. Equimolar mixture of both A as well as B, both of them are same. Just now we got. The first vapors formed will have more moles of A when compared to the moles of B. The first vapors, which means we have to calculate Ya as well as Yb. As we all know that Ya into Pt is equals to P naught A Xe. Ya is equals to Ya into 900, that is equals to P naught A value, we got it as 1000 into 1 divided by 2. Therefore Ya is equals to 500 divided by 900, that is equals to 5 by 9. Obviously Yb is equals to, definitely it is going to be 4 divided by 9. Here given that we got it as Ya is greater than Yb. So in the vapor, number of moles of A is present more than number of moles of B. P naught A 1020. No, P naught A is 1000 only. Next, the vapor pressure above the condensate will be 920 mm of Hg at the same temperature. The vapor pressure above the condensate. The vapor pressure above the condensate. There we have to calculate. Now, the vapor pressure above the condensate, that means XBC we know 0.4, XAC is equal to 0.6, and we got P naught A, P naught B. Just now we got P naught A is 1000 into 0.6 plus P naught B value, we got it as 800 into that value is equal to 0.4, which is equals to something around, this is going to be 0.6 now. So it is 16 plus P naught A plus P naught B, that is equals to how much? 1000 no? Therefore this is going to be some 600 plus it is going to be 80 into 4, 320. That is equals to 920 mm of Hg. So correct. So what equations are, what statements are correct? 1, 2 and 4. Yes. 1, 2, 4 are correct. So 1, 2, 4 are correct. Therefore option C is true. So what we have done first here, let us see. First we have taken the condensate as well as the residue. From that we have taken the relation between the initial number of moles of A as well as B. From that we have solved the entire expression. This is there in your DPP. Check once. The same question we have. Question number 39. H2 gas plus I2 gas gives rise to 2HI gas. Here given that this is K1 and it is K minus 1. The rate law expression. Select the correct expression. So from this minus d by dt of concentration of H2, that is equal to minus d by dt of concentration of I2, that is equal to plus 1 divided by 2 d by dt of concentration of HI, that is equals to K1 into concentration of H2 into I2 minus K minus concentration of HI square. Therefore, what is that expression? Minus d by dt of concentration of H2 is equals to K1 into concentration of H2I2 minus K minus 1 concentration of HI whole square. Therefore, option A is correct. Next, question number 40. The line correctly representing E0 cell versus LNKC. And if you look at it, then you can understand here Kc is given, which means at equilibrium. At equilibrium, E cell is equals to 0. E cell is equals to 0. Therefore, as we all know that Nernst equation, E cell is equals to E0 cell minus 0.06 divided by N log Qc. But at equilibrium, E cell is equals to 0 and Qc is equals to Kc. Substitute. E0 cell is equal to 0.06 divided by N log Kc. Now, if you plot the graph, then from this one, y is equals to mx. Therefore, it has to pass through the origin. So, which graph in that is passing through the origin? Where like this they have given the graph. O, A, B is given. Here ln Kc is given. Therefore, it has to pass through the origin. Therefore, graph OA. Such that option C. Option C. So, here option C. Next, question number 44. In question number 44, which of the following order is correct? Which is more than one option? So, order of paramagnetic nature. Order of paramagnetic nature. O2 is greater than, O2 plus is greater than, N2 is greater than, O3 is greater than, O2 minus. As we all know that, see, paramagnetic nature to calculate, no need to calculate every time square root of n into n plus 2. As the number of unpaired electrons are more, obviously paramagnetic character is also more. Number of unpaired electrons, O2 2, O2 plus 1, nitrogen N2 0. So till this extent this is true. But whereas in O3, number of unpaired electrons are 0. Paramagnetic character. In O2 minus, 1 unpaired electron is there. Therefore, here the order is not correct. Next. Number of anti-bonding electrons. Number of anti-bonding electrons. O2 2 minus, O2 minus, O2, O2 plus. As we all know that for O2, I am writing here pi star 2px1 is equals to pi star 2py1. Therefore, for this one, pi star 2px2 equal to pi star 2py2. Here number of antibonding electrons are 4, here 3, here 2, here 1. Therefore, that order is correct. Increasing order of bond angles. S double bond O, SOF2, S double bond O, Cl2, S double bond O, bromine, S double bond O, iodine. But actually here it is, it depends upon the size of the fluorine. Here in this case, iodine size is more, therefore in order to minimize the lone pair repulsions, it is going to be, it has to go a little wider. That's why the bond angle order SOI2 is definitely greater when compared with SOBR2, when compared with SOCl2, when compared with SOF2, that is true. Next, increasing order of the acidic strength. Magnesium oxide, basic. Carbon monoxide, neutral. B2O3, slightly acidic. N2O5, strongly acidic. Acidic strength, which is always to be calculated from their oxidation state, of course. This is basic, neutral, slightly acidic, strongly acidic. Therefore, correct. Therefore, option is going to be B, C, and D. B, C, as well as D. So, which is true. Next, when it comes to next question, if you look at the question number 45, when we look at the question number 45 here, Na2S plus Na2FeCN taken 5 times, NO they have taken, and it is reacted with Na2S, sodium sulfide, where it is forming what? Na4FeCN taken 5 times NOS. That is the reaction, and for that few expressions which are given, we will see what is that expression. So question number 45. In question number 45, what we have here, we will see. Yeah, in question number 45, Na2S plus Na2FeCN taken 5 times NO gives rise to Na4FeCN taken 5 times So we need the correct statement in this two. First of all, they are asking oxidation state of iron in both the complexes. This is here, if you want to calculate, this is 2 into plus 1 iron x plus 5 into minus 1 plus 0 is equal to 0. Therefore, x is equals to, here it is going to be NO plus 1. If you take, it is going to be NO plus na. So if it is NO plus, this is going to be plus 1. Now x is equals to plus 3 minus 5. Therefore, it is going to be plus 2. Now 4 into plus 1 plus x plus 5 into minus 1. This is because actually NO is plus 1, because of S minus 2 it becomes minus 1. Now it is going to be plus 4 minus 5, it becomes minus 1, minus 1, minus 1. Therefore x equal to plus 2. So in both the complexes, iron oxidation state is plus 2. Statement is correct. Both complexes can show isomerism. Both complexes can show isomerism. Yeah, definitely. Cyanide is there, no linkage isomerism it can show. What isomerism it can show? Linkage isomerism. One with carbon and another one with nitrogen. Definitely linkage isomerism is possible. Not like optical isomerism is not possible, geometrical isomerism is not possible, but structural isomerism is possible. They did not mention optical or geometrical, so just they mentioned isomerism, so that is possible. The given reaction is an oxidation reduction reaction. Absolutely not. It's just an addition reaction. There is no oxidation state was changed. Here sulfur oxidation state minus 2, sodium oxidation state plus 1. Here also same. The same thing is happened such that it's not at all a redox reaction. IUPAC name of the complex B is sodium pentacyano C linkage that we have to mention. So, and it is going to be pentacyano cyanide or cyano thionitrosoferrate 2. We have to mention that carbon linkage or nitrogen linkage, no? Therefore that is not going to be true. So that IUPAC nomenclature is false. So options are A as well as B. Sodium pentacyano or pentacyanide. C carbon linkage, C linkage. Thionitroso we have to mention. Thionitrosoferrate 2 complex. Next, question number 46. This is quite little interesting. This is all about the in this HCP, this is the HCP structure that we were already we know. Now in this, what are the questions? The common edge is C3 axis of symmetry. So which are correct? The common edge is C3 axis of symmetry. C3 axis of symmetry, which is nothing but we have to draw at an angle of 120 degrees. Here also just imagine like this. So you can take a imaginary C3 axis of symmetry like this. The common edge is C3 axis of symmetry, right? Next, each cell contains total 4 tetrahedral whites. Each cell, which means each part of this one. Actually, this is one HCP. No? This HCP we divide it into 3. In HCP, total number of tetrahedral whites are 12. Now we have it divided into 3. Therefore, 12 divided by 3, 4. So in each part of it, which means 1/3 part of it, we will be having the 4 tetrahedral whites. That is correct. Packing efficiency. Actually, packing efficiency of HCP is 74%. We all know. But it divided into 1/3. Therefore, 74 by 3. Each one 74 by 3, 74 by 3, 74 by 3. On the whole, that is going to be 74 by 3. No atom lie completely within the unit cell. That is correct. In HCP, first of all, in HCP, no atom lies in the cell. No atom is going to be lying in the HCP unit cell. That is all we were known. Next, question number 47. Given 1 mole of following carbides, which of the following will give more than 1 mole of hydrocarbon on hydrolysis? More than 1 mole of hydrocarbon on hydrolysis. So those are Al4C3 undergo hydrolysis gives 3 moles of methane. Be2C plus H2O gives rise to 1 mole of methane. This gives 1 mole of methane. Mg2C3 plus hydrolysis, it gives CH3, C triple bond CH. 1 mole of propane. Here it gives 1 mole of propane. This also gives 1 mole of propane. Na2C2 plus H2O gives rise to, it gives C2H2. So, given 1 mole of following carbides, which of the following will give more than 1 mole of hydrocarbon on hydrolysis? 100% yield. Who has given more than 1 mole of hydrocarbon? This one only given more than 1 mole of hydrocarbon. This has given only 1 mole of hydrocarbon, 1 mole of hydrocarbon, 1 mole of hydrocarbon. But only this can give more than 1 mole of hydrocarbon. Therefore, option A. 47 only option A. Next. Question number 51. Yeah, question number 51. In this question number 51, some paragraph is given. Chlorine disproportionates in basic as well as neutral medium. Chlorine in neutral medium, when it reacts with H2O, it converted to HCl plus HOCl. Yes, true. Chlorine in basic medium, for example, if it reacts with NaOH, it gives NaCl as well as NaOCl in weak basic medium. Whereas in strong basic medium, this is in weak basic medium. Whereas in strong basic medium, it gives NaCl plus NaClO3. NaCl plus NaClO3. Therefore, that option is true. Iodine disproportionates in basic medium. Correct. Iodine in strong basic medium, definitely it can dissociate it to NaOI plus NaIO3. This is also true. Next, sodium nitrite disproportionate in acidic medium. NaNO2 in acidic medium, it can be converted to NO3 minus and NO. There is one statement in your NCERT textbook also, that is, right from oxidation states +1, +2, +3 and +4 of fifth year group in strong acidic medium, they can definitely undergo disproportionation, which is given. Just check once. K2MnO4 disproportionates in acidic as well as in neutral medium. K2MnO4, which means MnO4 2-. MnO4 2- in strong basic medium, it can be converted to MnO2. This is green color converted to black. As well as MnO4-, as we know that it is a pink. Aqueous solution will be pink. In just by heating also the same reaction it can take place. MnO2 plus MnO4-. Therefore, 1, 2, 3, 4 all are correct. 51 option C. 51 option C. Next, 52. Question number 52. Here again, I guess we were discussed so many times that sodium hydroxide properties. So now here also they have given question number 52 in that Al+3 aqueous, when it reacts with the sodium hydroxide NaOH, it gives AlOH taken thrice. This is a white precipitate, as we know, which on excess amount of NaOH if you added, it can be converted to soluble salt of NaLO2. Correct. This statement is correct. If it is concentrated, it is a sodium meta-aluminate. If it is concentrated, it gives sodium aluminate. NaLO3 also, Na3LO3 also it can give. Zinc, Zn+2 reacts with NaOH, gives rise to ZnOH taken twice, which on excess, treated with excess, it gives Na2ZnO2. Correct. Next, Cu+2, which on reacts with NH4OH. First it forms CuOH taken twice, which on excess it forms CuNH3 taken 4 times, DsP2, sp2d. There is a big debate on it, so that complex we all know. Sn+2, when it reacts with NaOH, sodium hydroxide, forms SnOH taken twice, excess, it forms stannite, sodium stannite will be formed, that is Na2SnO2. It is also a precipitate. Now they are asking that which of the observations are correct. 1 is correct, 2 is correct, 3 is also correct, but this they have given no PPT is formed. Precipitate will be formed. If you remember, aluminum oxide, zinc oxide, PbO, PbO2, SnO2, all can form soluble precipitates. They all can form precipitates with excess. Whereas when it comes to the cations with ammonia, Cu+2, Cd+2, as well as another one or two cations are there. Even this zinc, they are all able to form the complexes with ammonia. So if you look at this paper, the quantity, which means the number of questions in this paper are very less. So what are the options? A1, A, B as well as C. Because the tin also can form, sodium stannite can form, but they have given it is wrong. So here in this video also, at the end of this video, I am telling you, when the discussion is going on, we are touching the relevant parts and why that option is right and why this option is wrong. So we are all discussing all these things. So hope you understand all these ones and see the complete videos, and for every subject you can understand it. It is not like we are free and we are making video. It is to help you. We are making video. Have a nice day. Bye.